So in section 1.5, we're going to be working with the graphs of sine and cosine functions. And we're going to learn how to sketch the graphs of basic sine and cosine functions. We're going to use amplitude and period to help sketch those graphs. We're going to sketch translations of sine and cosine functions. Remember, translations deal with moving the graph to the right and left, and up and down. And then we're also going to work with sine and cosine functions to model real-life data. So if we talk about sine and cosine functions, this is what they look like. This is a sine function. And this part here that's in dark black, this is one period. Okay, and what the period defines is a sine, or actually any trig function, falls into a repeating pattern. The smallest section that doesn't repeat, right, that involves no repetition, that's called the period. So this period, essentially, if I trace the period, you can see that this period repeats going in either direction. So the period is the section that will basically just repeat on and on and on and on as we go through right to left toward positive and negative infinity for our x values. Okay, and a sine function starts at the origin with no translation. It starts at the origin and it goes to an upper amplitude. This is an upper amplitude. It goes back to 0, then it has the lower amplitude, and then it goes back to 0. So when we're graphing, we're working with basically 3 different heights. And we're working with starting at 0, and then we split the period into quarters. Okay, and each quarter has a new point. So when I start at 0, 0. At the first quarter mark, I'm at the upper amplitude. At the second quarter mark, or halfway through, I'm back to 0. On the third quarter mark, I'm at the lower amplitude. And in the fourth quarter, when I complete the period, I'm back to 0. Okay? A cosine function does the same thing. It has the same 3 heights and the same quarters. The difference is, instead of starting at 0, 0, it starts at the upper amplitude. And then it moves to 0, to the lower amplitude, back to 0, and finishes back at the upper amplitude. Okay, so in fact, if you think about it, if I took this sine curve is essentially the same as the cosine curve, but they're 1/4 of a period different. Okay, so they're very similar. And so what we need to do is we need to know the period, and we need to know the range. And the range is this distance from 0 to the upper amplitude, from here to here. This is called the amplitude. And we move that distance up and we move it down. So our range is basically 2 times the amplitude. So we'd go the amplitude down and the amplitude up. In this case, the amplitude is 1. Okay, but in different problems, it may be different. So this is, again, talking about what I've already discussed with you, that we go from 0 to the maximum at the first quarter, back to the x-intercept, or 0, at the halfway point. 3/4 hits the minimum, and the full period, we're back to 0. And then it's just shifted by 1/4 when you're talking about a cosine curve. We just start at the maximum, intercept, minimum, intercept, maximum. Okay, so if I want to graph one of these, now they're asking me to graph it on the interval from -π/2 to 9π/2. Okay, so that means we're going to have to do some thinking. The basic format or the basic equation, so this is a cosine curve, right? A times the cosine of b of x, and I know that my period will be equal to 2π divided by b. So the first thing I'm going to do is find my period. 2π divided by b, that's b, it's not 6. Okay, so if you look at b, b is the coefficient times x, that's, in this case, it's 1. So 2π divided by 1 would be 2π. Okay, so when we're talking about π/2, that's only 4π/2. So I'm going to start by putting in the period. So let's say that this is 2π. And if I split that in half, I have pi. And this would be 3 pi over 2. And this is going to be pi over 2. This is 0. And over here would be negative pi over 2. All right, and I'm just going to go by pi over 2 each time. So let me take my little marks here, and I'm going to duplicate them, and I'm going to move them down. And we'll label them. So this would be, right, this would be, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, but that's 3 pi, 7 pi over 2, 8 pi over 2, that's 4 pi, and then I need another mark that's 9 pi over 2. Okay, so what I've done is I've created this interval. Now remember, my cycle is only 2 pi. So this, my period is only 2 pi. I said cycle. This is one cycle, right? One pass through the part that's going to repeat is called a cycle. We're doing more than one cycle. My amplitude is equal to A. So in this case, it's going to be 2. So we go 1, 2, 1, 2. And it's a cosine curve, so I start at the upper amplitude. In the next quarter of the period, I go to the intercept, then to the lower amplitude, then back to the intercept, and I finish out at the upper amplitude. So this would be one period or one cycle. But they want me to continue on, so then I'm going to go back to the intercept, back to the minimum, back to the intercept, back to a maximum, and then back to the intercept. So you notice each time I move a quarter, I change one level of height. And if I go back, it would have to go back down to the intercept. So now we're graphing the rest of what they asked for. And we did a little over 2 periods, right? We did basically 2.5 periods. So that's a period, and this is a half a period, not a half a period, a quarter of a period and a quarter of a period. Okay, so that's graphing when this set a sine curve, we were really doing a cosine curve. Okay, but the process is essentially the same. So we've talked about this in terms of amplitude. You'll notice these are 3 different functions with differing amplitudes. The light gray one is just y is equal to the cosine of x. And we put 1/2 out in front, you'll see the amplitude becomes smaller. And when we put 3 out in front, it becomes much bigger. So the amplitude stretches my graph or compresses my graph vertically. And then also when my amplitude is negative, we create what we'd call a reflection. And so in the case of a cosine curve, instead of starting at the maximum, I start at the minimum. But I still travel 1/4 at a time by changing one level of height. If it was a sine curve, I'd still start at 0, but then my first quarter I'd go to the minimum. Right, so this would be a reflected sine curve, what I'm doing here. So it would go boom, 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 like that. Okay, now when we talk about changes in the period, right, when we talk about this y is equal to the sine of x, it has a period that is 2 pi. But when this coefficient becomes 1/2, this is the same as y is equal to sine of 1/2 x. Right, when I do 2 pi divided by 1/2, that becomes a period of 4 pi, which is what you see here. You'll see when the period doubles that what's happened is my graph has been stretched horizontally. So the larger the period, the more it gets stretched horizontally. The shorter the period, the more it gets compressed horizontally. Okay, so remember, amplitude deals with vertical stretching, and period relates to horizontal stretching or compression. Okay, so let's do another graph. So if we go ahead and take this is y is equal to 1 times the cosine of 1/3 x. Okay, so I've just written it to make it easier to see that a is 1. so my amplitude is 1. And b is 1/3, so my period will be 2 pi divided by 1/3, which is 6 pi. Okay, so if we say that's 2 pi, 4 pi, 6 pi, let's say that's 6 pi, and 1 and 1. Then when we look at 6 pi, I want to split it. First I'm going to split it in half, right? So remember, this is 2 pi, 4 pi, and this becomes 3 pi. That's the middle, right? And halfway between 3 pi and 0 is 1.5 pi. So over here I'm going to do 3 pi over 2. That's right about here. And that's one of my points. We're doing cosine, so we're starting at the upper amplitude. And then over here, halfway between 3 pi and 6 pi is going to be 4.5 pi, right? Which is going to be 9 pi over 2. And that's going to be another point. So from cosine, I'm going to start at the upper, go to the intercept, then down to the minimum, then back to the intercept, and I'm going to finish at the maximum. And that's what my graph looks like. So you can see this graph is rather stretched. I didn't really have to put in the 2 pi and the 4 pi. I just wanted to help lay out and make sure everybody understood sort of the relative horizontal distances. All right, so now in the same coordinate plane, we want to graph these two. Now look what's going to happen. When you look at it, you can see that what's different about them is the amplitude. All right, so what I'm going to expect is that these are going to be different in some sort of a vertical measure. Right, so I know that my period is going to be equal to 2 pi over b, which b is 1. So it's going to be 2 pi for each one of these. So let's say this is 2 pi. That makes this pi. 3 pi over 2. Pi over 2. And first I'm going to graph this one. So it's a sine curve, so I start at 0, 0. Here I'm at the maximum, which is 1/3, then back to 0, then the minimum, which is negative 1/3, and then back to 0. So you see that this is a very, very flat graph. Now when I work with this one, I'm going to start at 0, 0, but when I go to the maximum, it's 3, and then back to here, and then down to negative 3, and back to here. And so you can see, as we did in that example graph, that what changes when A changes is a vertical stretching. Right? This is more vertically stretched, and this one is vertically compressed because of the leading coefficient. Okay, now when we talk about translations, we're looking at adding in this case we're talking about horizontal shifts. I'm going to write this out more in the way that your Algebra 2 book would have written it. This would be bx minus h plus k. All right, so remember, h is a horizontal change, k is a vertical change. The fact that your book's calling them c and they're going to call the k value something else, but I wanted to make this a little more familiar. It's still the same idea. That h is going to make a horizontal change, and k is going to make a vertical change. The calculating amplitude and period is still the same. Right, and they talk to me about how my right and end points are going to shift because they're going to shift by finding the value of the h and the k. Okay, so if we go through going ahead and graphing that, right, I know that I have an amplitude of 2 because a is 2. I see that the leading coefficient with x is 1. So now my period is going to be 2 pi over 1, which is 2 pi. And I see that everything is going to be shifted pi over 2 to the right. Everything's going to shift pi over 2 to the right. So let's say that I lay it out like I would normally. 2 pi, pi, 3 pi over 2, pi over 2. And remember, everything shifted by pi over 2. So this is 4 pi over 2. I'm going to add in 5 pi over 2. And what I'm going to do is I'm going to show it to you first in the original form of what it would look like. Right? 1, 2, 1, 2. We'd have a point here, then a point here, then a point here, then a point here, and then a point here. If I didn't have my h value, but everything is going to shift. I'm going to take each point and I'm going to shift it by pi over 2 to the right. And because, basically we always work off a starting point, if I had just started off and shifted it to the right, that would have been okay. Right? So I could have I didn't have to put this particular graph in. Right? This is the graph of y is equal to 2 cosine x. That's the red graph. And you see by putting in this minus pi over 2, it shifted everything to the right by pi over 2. Okay, that's what a translation does. And it can shift to the right, it could shift to the left, it could also shift up and down or any combination of those. So if we take a look at this, now what I would normally do, so I am going to be doing some things that are slightly different than the way the book demonstrates things. I'm going to rewrite this as y is equal to -1/2 sine, and then I'm going to factor the pi out of that, x plus 1. All right, so the things I know, a is equal to -1/2. That means my amplitude is 1/2, but this is also a reflection. So that's going to change the pattern I follow. And I know that my h value is equal to -1, which is going to be a shift to the left of 1. I know that my b value is pi, so I know that my period is going to be 2 pi over pi, which is 2. All right, and now I'm going to go ahead and I'm going to graph all of this. So if we say that's 1 and that's 2, that means this is 3/2 and this is 1/2. And I know everything's going to be shifted by 1. So if normally I started, but it's going to be 1 to the left. So normally if I started here, let's go ahead and move everything so that I got a little more room. Right? If normally I would start here at 0, I'm going to have to go to the left 1/2 and -1. So I'm going to start all the way over here. It's a sine curve, so I start there, and it's a reflection, so on my first quarter, instead of going up, I'm going to go down. Okay, but my amplitude is only 1/2, so let's make that 1, and that's -1. So when I go down, I'll go to -1/2, and then to 0, and then to +1/2, and then at 1 I finish out here. Okay, so you see this graph was shifted 1 to the left, and it was also reflected because my leading coefficient was negative. Okay, and I personally prefer to factor this out. That's not necessarily the way that the book shows you how to do it, but I think that's much simpler to do. Okay, over here we're looking at one that's a little more simple than the last one. So I know my amplitude is equal to 2, because that's 2. I know that in this case h is equal to 0. There's nothing in parentheses with the x. I know that the period is going to be 2 pi over b, and b is 1, so that's going to be 2 pi. And I know that k, the thing being added on here at the end, is -5. So what that means is everything's going to get shifted down by 5. Okay, so let's go ahead and put in our period. Our period is 2 pi. And again, we're going to do pi. You'll notice that some of these things get done pretty repetitively. 3 pi over 2, pi over 2. And then my amplitude is 2. But remember, everything's going to be shifted down 5. So part of what happens, and this is something that we haven't talked about yet, 2, 3, 4, 5, is that conceptually here, this x-axis, which is the center of my graph, has been shifted down 5 by my k value. Now from here, I can go down 2 and up 2. And when I go ahead to graph this, I'm going to start here at the upper amplitude. Then I go to the intercept, the lower amplitude, also called by your book the minimum, back to the intercept, and then back to the upper amplitude. So the graph looks like this. Okay, so it's been shifted down by 5. Otherwise, if I just graphed y is equal to 2 times the cosine of x, if I had just graphed that, that would have been here. Right? This would have been the parent function, y is equal to 2 cosine x. But when you add in the minus 5, it takes everything and it moves it down 5. Okay, when we talk about finding trigonometric models, they've given me some data, some information. If I wanted to find a sine model, you notice it's a sine model, that's important, then how would I go about graphing this? So what I want is, right, y would be equal to a times the sine of potentially x. Or it might be in the bigger form, y is equal to a times the sine of b times x minus h plus k. So it could be in either of these forms. But I've got to sort of figure this out in terms of what do I have? Right, so what I might want to do is I might want to make a scatter plot of some sort. So let me go ahead and make a scatter plot. Oops, my content pictures. So if I go ahead and make a scatter plot, this might give me some sort of sense of what's going on. So at 0, we're at 3.4, so 1, 2, 3.4. And at 2, 1, 2, we're at 8.7. So let's see, that's 4, 5, 6, 7, 8.7, so almost to 9. And at 4, another 2, we're at 11.3. And then at 6, see, 2, 4, 6. So I've messed this up a little bit. So see, at 2, we're at 8.7. I got a little off there. And 3, 4, we're at 11.3. Okay. And then 5, 6, we're down to 9.1, which is about there. And then if we look at 8, that's here, we're at 3.8. So this one was 3.4. 3.8 is almost 4. Okay, and at 10, we're down to 0.1. And at 12, we're at 1.2. All right. So now what we don't know is we don't know what's going on with, we don't necessarily know what's going on with h, but I can certainly see that a k is in here. So if I just start thinking about it, there's probably a k value put in here someplace. I'm trying to sort of guesstimate about where's the middle of this graph. Where is it? Right? It might be right around there. So what we're going to do is we're going to identify our maximums and our minimums. So this was a minimum, and you can see that this is a maximum. Okay, so one of the things that we can determine, if that's the minimum and that's the maximum, there are two things we can find from that. First off, we know that halfway between the two is where my center line is for this function, and that's also going to determine what our k value is. So if I have 11.3 plus 0.1 divided by 2, that's going to be 11.4 divided by 2, which is 5.5 plus 0.2 is 5.7. Okay, so my guesstimate wasn't so bad. 1, 2, 3, 4, 5. We're going to move this up a little bit. let's say that's about 5.7. So the center of my graph is 5.7, and I'm just going to notate over here that k is equal to 5.7. Great. Now the other thing it has told me is if I take a look at here and here, the horizontal distance, the distance between, in a sine function, right, the distance between my maximum, my minimum is 2/4 of the period, which is 1/2 of the period, so that this distance is half the period. So 10 minus 4, this distance is 6, is half the period, so the period is equal to 12. Okay, great. So when we start looking at that, I know that 2 pi over b is equal to 12. That means that 2 pi is equal to, divided by 12 would be equal to b. So that would be, b is pi over 6 is equal to b. So I can start writing my function here. I know I'm going to need an amplitude, and I'm going to have, sine. I'm going to have pi over 6 times x, and there's going to be some sort of an h value here, right, plus 5.7. Okay, at least we're assuming, right, because where my graph begins is going to be somewhere along this line. Okay, but what I need to know is I need to know, right, it would be at where the graph begins is going to be related to this. So if I went 6 in here, and I'm going to total go 12, 1, 2, 3, this is going to be my starting point here. And if I go 1, 2, 3, this is going to be my ending point, because that's adding another 6. This is the center half. I add a quarter on either side. So my starting point is going to be 1. That means my graph is shifted 1 to the right. So this is 1. And now I need to find my A. Okay, well, my A is the amplitude. Remember, we figured out the amplitude here. It was the difference between, it will actually be the difference between 5.7 and this upper area. So this is the amplitude. So if we do 11.3 minus 5.7, it's going to be 0.6, and 10 minus 5, so 5.6. So this item is going to be 5.6. And now we've gone ahead and rationalized it out. Now you might have looked at this and thought, oh, I'll create a system. Yeah, you could have created a system, but it really would have been difficult. Because if I created a system with this, I have 4 variables. I have A, B, H, and K. I'd need 4 different equations in order to solve that. In this case, examining the function was much simpler than trying to create a system. Okay, so again, a deep understanding of what makes a sine function and a knowledge of how that relates to a graph allows you to then pick the important pieces out of it and plug them into your equation. Okay, so let's go through what we've done in this particular section. So we've gone through the graphs of sine and cosine functions. We've gone through sketching them. We've used amplitude and period to help us sketch those functions. And we've gone through translations, and we've also done reflections, right? But they tied reflections in with amplitude, essentially, so negative amplitude. And then we've gone through modeling sine and cosine functions to model real-life data. Oh, I'm so sorry. I forgot to tell you. This data was all related to tides. So the tides, the process of the height of the tide over time can also be modeled by a sine and or a cosine function, depending on where you start. Okay, so where we started, right, if we're starting at the 0 point, we're starting halfway between high and low tide. If I started with a cosine function, I'd be starting at a high tide. Okay, so I'm sorry, I didn't relate initially what we were talking about when we were doing the modeling problem, but that was what this problem was all about, was time and depth of the ocean.